y'all remember doing this? Yes? Do you remember simplifying? Because this part is just simplify our radical. So on number 1, if we try to simplify that, do you remember like what we did to simplify these?
We like did a branch or whatever.
Yeah. We made that tree. What number is multiplied to give you 45?
5 and 9.
5 and 9. And then numbers that multiply to give you 9. 3 and 3. So what would that simplified answer be?
3
or 5? What about number 2? What about if we did number 2? What number is multiplied to give you 12? 4 and 3, and then 2 and 2. So 2 root 3. Yeah, you can do the tree, or you can do the trees different ways, but you get the same end answer simplified. This all kind of coming back to you. Let's go across to this number 7, 3 root 50. The square root of 50, we need to simplify. What number is multiplied to 50? 25 and 2, 10 and 5, they would all get you the same answer. Numbers that multiply to 25. Okay. So what gets to come out? But when there's something already out there, they multiply. So 15 and then square root of 2. What if we went up to number 6? Numbers that multiply to give you 32. 4 and 8, okay. 4 would be 2 and 2. 8 would be 2 and 4, and then 2 and 2 again. So it's a lot of 2's. How many pairs of 2's come out? 2. Okay, so that means we have 2 pairs of 2's, which means that's really what number on the outside? A 4, but since there was something already out there, multiply them. So what's our 4 times 2? And then what's left inside? 2. That one had a lot of 2's going on. I'm aware. Okay. Does this kind of all feel familiar? Like, oh yeah, I remember doing this. Square rooting stuff, simplifying. So we're going to be square root, or like taking the square root stuff today. Every time ever that I've ever given y'all a problem that involves some sort of square root, I've always asked for the simplified version. That is no different today. So as we go through our stuff today, it has to be as simplified as possible. So let's go to the bottom part. Take the square root of each number. What's the square root of 49? Okay. What's the square root of 25? What about the square root of 12? We did it already. Look up at your paper. What was our answer?
2 and 3. 2 square root 3.
2 square root 3, 2 root 3. Okay. Why is the square root of 49 7?
Because 7 times 7.
Because 7 times 7 is 49. That's how we get our square root. What number times itself would give you this 49? We're missing something.
Square root of
No. 7 is not the only answer. What else? Would negative 7 times negative 7?
Yes.
So the square root of 49 is not just 7, it's also negative 7. Which means it is also negative 5 and a negative 2 square root of 3. I mentioned this little situation way back in like the first 6 weeks. And I said, no, let's not worry about it. We'll worry about it later. Well, now later has happened. So now you have to give me the positive and negative version when we're taking the square root of something. Now you can write it like this. Use a comma, just separate the two, positive and negative 7. Or you can write it like this. Positive, negative 7. Have y'all seen this symbol before? We say it as plus or minus, exactly like what it looks like. It means the positive 5 and negative 5. It means positive 7 and negative 7. It just makes it where you don't have to write the number twice. You just write both signs right in front of it. We are going to see that plus minus sign a lot in the future. coming up in a different section that we had later on. Okay. So we're going,
For the 2 negative 3, why does it why for the 2 3, why doesn't the 3 inside the bracket
because they're connected. They're all one term. If it was we'll talk about a negative under the rest. Okay, so if you turn to the next page, we're solving problems. We're solving quadratics today. We have solved all these problems before. We've done this with factoring. We've done all of that, but we're going to do it a different way today. There's a reason we get to do it a different way today. We have done quadratics. Our standard form of quadratics looks like this, the ax squared plus bx plus c equals 0. Okay, so we have been solving problems like that. We are solving these by factoring. What's different in this first example that we have? There's no just like x. There's an x squared, but there's no x. When that happens, we don't have to factor these. There's an alternative. We're going to learn a few other ways other than just solving by factoring. So today is day 1. We're going to solve by taking the square root. How to solve by taking the square root? You have to have on one side of your equation something squared, whether it's an x or just whatever it is, something squared. And then the other side just has to be a number. If we can get that, then we can solve by doing square roots. I put a something there because there's a reason. If you can kind of look above, or look later on in your problem. We just need one side to be something squared. Once one side is something squared and the other side is just a number, then we can take the square root of both sides and solve it. So it's not having to do that factoring step. So if you look at A, we need to get where one side is just something squared and the other side is number. So what do we have to get rid of on this one side? 8. How do we move the 8 over? Solving like normal. So 2x equals 8. We need to get that one side to just be something squared. So what do we still have to do? Divide by 2, because the 2 is not being squared, it's just x. So x squared equals 4. Once you get to this step, where one side is something squared, the other side is just a number, well, how do you undo squaring something? Which is why we just have to go back over simplifying square roots. Undoing something squared is taking the square root of it. And rules of solving equations, when you do it on one side, you do it on the other side. Taking the square root of something squared just takes away the square. So we're left with just x. And then what's the square root of 4? What did we just talk about though? Positive 2 and a negative 2. So positive and negative 2. If you don't give me both, if you just tell me a positive 2, well, you just missed half the answer. You have to make sure you're including both. So let's try part B. On part B, we need to get one side to just be something squared. So what do we have to do first?
Minus 6.
Subtract 6. So 3x squared equals 27. One side, just something squared. So what do we still have to do?
Divide by 3.
Divide by 3. So x squared equals 9. Did we get one side to be something squared and the other side is now just a number? Which means we can do our square root step. So what's the square root of 9?
3.
And
Positive and negative 3.
so a positive and negative 3. Okay. Try part C. We're going to move on to part D. What's different? D through G, what's different about all those?
They have parentheses.
They have parentheses. But it's still the same concept. Is one side something being squared? Is the other side just a number? Is that happening? Is there anything around the parentheses being squared? Is it being multiplied by something, adding, subtracting, anything? Okay, so that is really something squared, and the other side is just a number. Which means we can go straight into taking the square root of each side. Taking the square root of something squared means you take away the square part, so we are left with x plus 15. Whatever was inside those parentheses being squared.
Equals 9?
Almost.
Oh, negative.
A positive or negative 9. Now, where this is a little bit different, have we completely solved for x?
No.
Okay. That means we are going to have to solve this equation, but 2 different times. Because it's saying that x plus 15 equals 9. Which means we would subtract 15, so what would that answer be?
6.
Negative 6.
Plus 1 is 4.
And then the other thing that this equation is originally saying is that x plus 15 also equals a negative 9. So we have to solve our equation 2 different times. We would subtract 15. Negative 9 minus 15 is negative 24.
X equals 2.
So you have to solve the equation twice. The plus or minus is just part of it, but then we have to break it apart and solve it once when that number is positive and once when that number is negative. So let's go to part E. On part E, do we have just something squared? No. What's around it? That's 3, and it's multiplying by our thing squared. So divide by 3 first. So x plus 1 squared equals 9. Did we now get it to the goal of something squared on one side and then a number on the other side?
Yes.
Okay, that means we are ready to go to take the square root of each side. That eliminates the parentheses and the squared part, so it's x plus 1 and plus or minus what number? 3. So we are now solving that equation 2 different times. Once where x plus 1 equals a positive 3, and again where x plus 1 equals a negative 3. So this is saying, well, what's 3 minus 1?
2.
2, so that's one of our answers. And now what's negative 3 minus 1?
Negative 4.
So that's our other answer. Okay. What about if we go to F?
49.
Before we solve it, we would have to subtract 5 first. So x minus 12 squared equals 49. Finish it up. I want you to finish. So we're going to go to G. So on G, do we have something squared on one side, number on the other side? And that's no prior work. All we have to do now is square root each side. So we're left with 4x minus 3. And then what's the square root of 64?
8.
Positive or negative 8. So we're going to solve it twice. 1 square 4x minus 3 equals the positive 8. And 1 square the 4x minus 3 equals a negative 8. But now we just have 2 steps to solve for x this time. We're going to add 3. So if we do 8 plus 3, that gives us 11. And then what? Divide by 4. Can you divide it and get a whole number next to your numbers? Okay, so we can keep it as 11 fourths. And then on the other side, it's 4x, but now we have negative 3, or negative 8 plus 3, which is negative 5. And then can we divide negative 5 by 4 and get a nice free number? No, but we can just leave it as negative 5 fourths. And ta-da. Okay. All of those so far have worked out because we had a perfect square on that one side. It wasn't a simplified radical. We're going to get into H, something a little different. On H, what do we have to do first? Multiply.
Divide.
By 4. There we go. So x plus 3 squared equals 10. Now what? We can square root both sides now. So we have x plus 3. The square root of 10. If we make a tree for 10, what numbers multiply to give you 10? Are we getting any pairs out of that? No. So positive and negative square root of 10. Because we can't simplify. I don't want you ever to get decimal versus that. That's what we have so far. Now, if we split it apart, we would still have to subtract 3, right? So it would be a positive square root of 10 minus 3, and then a negative square root of 10 minus 3. Can we subtract those and get like a new number?
No.
Radicals are like terms. We can't combine, we can't do anything with them unless they're the exact same radical. Just like x's. You can only combine x's with other x's, or y's with other y's. Since that 3 doesn't have a square root of 10 with it, these are going to stay as 2 separate things. So this is your answer. But I am particular about how I write it, and there's a reason behind it. I don't like putting a number without a radical behind a radical. The reason all y'all get real quick and careless and like end up somehow where someone's paper is going to look like this. And then you're going to try to tell me it's a square root of 7. And that is not right. So to avoid any of that problem, I just switch it. I put the negative 3, instead of having it minus 3 at the end, I put it in the front. So I would make it negative 3 plus the square root of 10. I just flip it. And I do one better, make it even shorter. Because it would be negative 3 plus the square root of 10 and negative 3 minus the square root of 10. We just already answered that. The next one is similar, so we can practice all that again.
Oh no.
So if we look at I, we want to solve for that x, so what's our first step going to be? Add 8. So x minus 1 squared equals 80. Then take the square root. 80 can actually simplify a little bit. Numbers that multiply give you 80.
40 and 2.
40 and 2. Okay, numbers that multiply to give you 40.
4 and 10.
4 and 10. Numbers that multiply to 2 and 2 and 5.
So 4.
So 4 square root of 5. Okay. We have the same thing again, where we will have to move that 1 over, but 1 can't combine with 4 square root of 5. When that 1 moves over, is the 1 going to be positive or negative? Positive, because you have to add it to move it over.
That's a negative.
So we would have a positive 1 on that side, and plus or minus 4 square root of 5.
Yay.
You'll have a little bit of that to practice for your homework, so that'll be okay. Yeah. Okay. So we're going down to the word problems. On that first one, the area of walls covered by a rectangular poster is 320 square inches. The length of the poster is 1 1/4 times longer than the width of the poster. So then what are the dimensions? Talks about area. Area is length times width, so we need to write out the length and the width. How do we describe the length?
1.25 times.
Okay, so how would I write that algebraically? The length, it said it was 1.25 times the width. And then can't we just call the width W then? or x if you prefer x. It tells us the area is 320. Multiplying these two together, so what's w times 1.25w?
1.25 W squared.
W squared, right? W times w squared. So 1.25 w squared equals 320. Okay, solve like normal. Do we have one side where it's just something squared, the other side's a number? Divide by 1.25 first. Who's going to help us with that? Division?
16.
No.
W equals 6.
Okay, what do you have before the 16?
320 divided by 1.25 is 256.
256. Now do we have something squared and the other side's just a number? What's the square root of 256?
16.
Okay. Plus or minus 16. Word problems. Does that make sense now for both answers? What's W representing? A width of a poster. Do both those answers make sense for the width of a poster? What makes sense for the width of a poster? A positive 16. So the width is a positive 16.
Equals 16.
And the length, how would you get the length?
16 times.
Yeah, multiply this by 16, which is what? Okay. Let's go to K. Nice part in K. If you look at that third word, it gives you the equation. So the equation D equals 16t squared gives the distance D in feet that a golf ball falls in t seconds. How many seconds will it take a golf ball to drop to the ground from a height of 4 feet or 64 feet? So we're solving two different things. It's asking about 4 feet and it's asking about 64 feet. What are 4 and 64 going to plug into for that equation? Our distance. So 4 equals 16t squared. And we have to solve for t. We want to find out that time. What would you do to solve for t in this one? Divide by 16. We can't divide 4 by 16 and get a nice like whole number, but it's a fraction. What's the simplified fraction of 4 over 16? 1/4. Now that's t squared. So what do we still have to do to solve this? Square root it. Now when it comes to fractions, we square root the top, we square root the bottom. Can we get the square root of the denominator? Can we get the square root of 4? 2. Can we get the square root of 1? Yeah. So that means our t value is 1/2. Positive and negative 1/2. Do both of those make sense? What is t in that problem? Time, second, so what would be our answer? Half a second. We're going to do the same thing for 64 feet. What would our first step be? Divide 64 by 16, which is 4. So if t squared is 4, then what's t? What number squared is going to be 4? 2. Would the positive and the negative work for this? Okay, so only the positive works. So 2 seconds. Okay. Last one. Throw a little geometry into. So we have a right triangle.
Oh no.
It has a hypotenuse of square root of 23. What part of that triangle is the hypotenuse? So this is the square root of 23. One leg is the square root of 3. The other leg is x. Solve for the missing leg. Remember how to solve things with right triangles. A squared plus b squared equals c squared. So that means we're going to have x squared, b squared. So the square root of 3 squared. What do you get if you have the square root of 3 squared? 3. If you're squaring something that is square rooted, they cancel out. So we're left with 3. So look, square root of 3, square.
Equals
These cancel each other out. So we're left with just the 3.
Oh.
So that'll equal
And then it's the same thing, minus 3.
same thing, subtract 3, so x squared equals 20. Can we simplify this? Because well, we're going to have to do the square root of 20. Can we simplify that?
10 and 2.
10 and 2, and then 5 and 2. Oh, we have a pair. So 2 root 5.
Obviously, we're negative.
Would both positive and negative values work?
Yes, no.
Yes.
What is x? The side of a triangle. Would both measurements make sense for the side of a triangle?
No. So it's positive.
Just the positive. Now, what you be careful with, don't automatically always cancel out the negative. Check to see what was x actually representing, because sometimes x is part of an expression. If it was part of an expression that was like x plus 12, well, 12 plus a negative 2 root 5 would still be a positive answer. Don't pack up yet. There's one more part I want to talk about. Real quick. So this next page is your homework. This page is your homework. But I want to do one together. I want to do number 1 together. What would we do to solve number 1?
Minus 64.
Subtract 64. And then we would take the square root of it. Right? Who has a calculator? Type in the square root of negative 64.
Oh my god.
Non-real calculation.
It says non-real calculation. So the answer to this, the reason it's saying that, there was a negative in the square root. You, like, taking the square root of a negative number, that is no real solution. Now, where that comes into play, when you get into Algebra 2, the square root of a negative number, you start learning about things called imaginary numbers. For now, we don't have to worry about it. We can write no real solution. Just make sure you include that word real. That's different. Okay, now you can type out the